Let's begin this chapter with some examples. We have observed in nature objects such as petals of a flower, holes of a honeycomb, grains on a maize cob, spirals on a pineapple, etc. We notice that these objects follow a certain pattern. Now let's move to day-to-day like situations. Situation 1. The display of soaps in hypermarket consists of 15 rows, each containing 4 fewer soaps than row below. Situation 2. Raja has salary of 6,000 and an annual increment of rupees 700. Situation 3. The city sets a fine of rupees 500 for driving without helmet. This fine increases by rupees 200 for each subsequent offences. In the examples, we notice that there is some pattern followed. We find that the succeeding terms are obtained by adding a fixed number, in other by multiplying with a fixed number, in another we find that they are squares of consecutive numbers, and so on. In this chapter, we shall discuss one of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms. We shall also see how to find the nth terms and the sum of n consecutive terms. At the end of this chapter, you will be able to explain arithmetic progression, find the nth term of an AP, find the sum of first n terms of an AP. Arithmetic progression, an introduction. Consider the list of numbers and write your observations on number pattern. 1, 2, 3, 4, 100, 70, 40, 10, -3, -2, -1, 0. Note, each of the numbers in the list is called a term. Observations. In 1, each term is 1 more than the term preceding it. In 2, each term is 30 less than the term preceding it. In 3, each term is obtained by adding 1 to the term preceding it. In all the lists above, we see that successive terms are obtained by adding a fixed number to the preceding terms. Such list of numbers is said to form an arithmetic progression, AP. Some features of AP are: an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. The fixed number is called the common difference of the AP. It can be positive, negative, or 0. The minimum information needed to know about AP are: first term A, common difference D. A. The heights in centimeter of some students of a school standing in a queue in the morning assembly are 147, 148, 149, up to 157. B. The minimum temperatures in degrees Celsius recorded for weeks in the month of Jan in a city arranged in ascending order are -3.1, -3.0, -2.9, -2.8, -2.7, -2.6, -2.5. C. The balance money in rupees after paying 5% of the total loan of rupees 1,000 every month is 950, 900, 850, 800, up to 50. D. The cash prices in rupees given by a school to the toppers of classes 1 to 12 are 200, 250, 300, 350, up to 750. E. The total savings in rupees after every month for 10 months, when rupees 50 are saved each month, are 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. A. The heights in centimeter of some students of a school standing in A. The heights in centimeter of some students of if A1 is the first term of an AP, A2 second term of an AP, and AN is the nth term of an AP, D the common difference, then the AP becomes A1, A2, A3 up to AN. So A2 minus A1 is equal to A3 minus A2 is equal to dash dash up to AN minus 1 equal to D. We can see that A plus D, A plus 2D, A plus 3D represents an arithmetic progression where A is the first term and D the common difference. This is called the general form of an AP. In examples A to E, there are only a finite number of terms. Such an AP is called a finite AP. Also note that each of these arithmetic progressions, APs, has a last term. The APs in example 1 to 3 are not finite, so they are called infinite arithmetic progressions. Such APs do not have a last term. Let us make the concept more clear through some examples. For the AP, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2, write the first term A and the common difference D. Solution: A is equal to 3 by 2, D is equal to 1 by 2, minus 3 by 2 equal to minus 1. Remember that we can find D using any two consecutive terms once we know that the numbers are in AP. After working an example on AP, let's perform an activity. You can view list of numbers, drag and drop the following list of numbers which form an AP. Rajan had offered the job with a starting salary of rupees 8,000, with an annual increment of rupees 500. We'll try calculating his salary for fourth year. To find the salary of the fourth year, first we need to calculate his monthly salary for the second year. That is, rupees 8,000 plus 500 equal to rupees 8,500. The same way we can find the monthly salary for the third and fourth by adding rupees 500 to the salary of the previous year. Salary for first year is equal to rupees 8,000. Salary for rupees second year is equal to rupees 8,000 plus 500 equal to rupees 8,500. Salary for third year is equal to rupees 8,000 plus 500 plus 500 equal to rupees 8,000 plus 2 into 500 equal to rupees 8,000 plus 3 minus 1 into 500 equal to rupees 9,000. Salary for fourth year, rupees 9,000 plus 500 equal to rupees 8,000 plus 500 plus 500 plus 500 equal to rupees 8,000 plus 3 into 500 equal to rupees 8,000 plus 4 minus 1 into 500. Observations. Just write down the salary for first, second, third, and fourth year. We can observe that numbers are in AP. Observe that we are getting a list of numbers 8,000, 8,500, 9,000, 9,500, 10,000. These numbers are in AP. Now let's calculate Raja's salary for 15th year. Salary for the 15th year is equal to salary for the 14th year plus rupees 500 equal to rupees 8,000 plus 500 plus 500 plus 500 plus 500 13 times equal to rupees 8,000 plus 14 into 500 equal to rupees 8,000 plus 15 minus 1 into 500 equal to rupees 15,000. That is, first salary plus 15 minus 1 into annual increment. Salary for 25th year. In the same way, his monthly salary for the 25th year would be shown. Salary for 25th year. Rupees 8,000 plus 25 minus 1 into 500 equal to rupees 20,000. That is, first salary plus 25 minus 1 into annual increment. This example would have given you some idea about how to write the 15th term or the 25th term, and more generally, the nth term of the AP. Let A, A1, A2 be an AP whose first term A is A and the common difference is D. Then the second term A is equal to A plus D equal to A plus 2 minus 1D. The third term A is equal to A1 plus AD equal to A plus D equal to A plus 2D equal to A plus 3 minus 1D. The fourth term A is equal to A plus D equal to A plus 2D plus D equal to A plus 3D equal to A plus 4 minus 1D. Looking at the pattern, we can say that the nth term of A is equal to A plus n minus 1D. So, the nth term A of the AP with first term A and common difference D is given by A is equal to A plus n minus 1D. A is also called the general term of the AP. If there are m terms in the AP, then A represents the last term, which is sometimes also denoted by L. Let us consider some examples. Example 1. Find the 10th term of the AP 2, 7, 12. Solution. Here, A is equal to 2, D is equal to 7, minus 2 equal to 5, and N is equal to 10. We have A is equal to A plus N minus 1 into D. So, A is equal to 2 plus 10 minus 1 into 5 equal to 2 plus 45 equal to 47. Therefore, the 10th term of the given AP is 47. Which term of the AP 21, 18, 15 is minus 81? Also, is any term 0? Give reasons for your answer. Solution. Here, A is equal to 21, D is equal to 18 minus 21 equal to minus 3, and AN is equal to minus 81, and we have to find N. As AN is equal to A plus N minus 1 into D, we have minus 81 equal to 21 plus N minus 1 into minus 3. Minus 81 is equal to 24 minus 3N. Minus 105 is equal to minus 3N. So N is equal to 35. Therefore, the 35th term of the given AP is minus 81. Next, we want to know if there is any N for which AN is equal to 0. If such an N is there, then 21 plus N minus 1 into minus 3 is equal to 0. That is, 3 into N minus 1 is equal to 21. That is, N is equal to 8. So, the 8th term is 0. Example 3. Determine the AP whose third term is 5 and the 7th term is 9. Solution. We have 8 square is equal to A plus 3 minus 1 into D equal to A plus 2D equal to 5 into 1. And A7 is equal to A plus 7 minus 1 into D equal to A plus 6D equal to 9 into 2. Solving the pair of linear equations 1 and 2, we get A is equal to 3, D is equal to 1. Hence, the required AP is 3, 4, 5, 6, 7. Example 4. Check whether 301 is a term of the list of numbers 5, 11, 17, 23. Solution. We have a2 minus a1 equal to 11 minus 5 equal to 6. a3 minus a2 is equal to 17 minus 11 equal to 6. a4 minus a3 is equal to 23 minus 17 equal to 6. ak plus 1 minus ak. As a minus a is the same for k equal to 1, 2, 3, etc. The given list of numbers is an AP. Now, a is equal to 5 and d is equal to 6. Let 301 be a term, say the nth term of this AP. We know that and a is equal to a plus n minus 1 into d. So 301 is equal to 5 plus n minus 1 into 6. That is, 301 is equal to 6n minus 1. So n is equal to 302 upon 6 equal to 151 upon 3. But n should be a positive integer. So 301 is not a term of the given list of numbers. How many two-digit numbers are divisible by 3? Solution. The list of two-digit numbers divisible by 3 is 12, 15, 18, up to 99. Is this an AP? Yes, it is. Here, a is equal to 12, d is equal to 3, a is equal to 99. As a2 is equal to a plus n minus 1 into d, we have 99 equal to 12 plus n minus 1 into 3. That is 87 is equal to n minus 1 into 3. That is n minus 1 is equal to 87 upon 3 equal to 29. That is n is equal to 29 plus 1 equal to 30. So there are 30 two-digit numbers divisible by 3. Example 6. Find the nth term from the last term towards the first term of the AP 10, 7, 4 up to minus 62. Solution. Here a is equal to 10, d is equal to 7 minus 10 is equal to minus 3, L is equal to minus 62, where L is equal to a plus n minus 1 into d. To find the 11th term from the last term, you will find the total number of terms in the AP. So, minus 62 is equal to 10 plus n minus 1 into minus 3. That is, minus 72 is equal to n minus 1 minus 3. That is, n minus 1 is equal to 24, or n is equal to 25. So there are 25 terms in the given AP. 11th term from the last term will be the 15th term. So a 12 is equal to 10 plus 15 minus 1 into minus 3 equal to 10 minus 42 equal to minus 32. That is, the 11th term from the last term is minus 32. Alternative solution. If you write the AP in the reverse order, then a is equal to minus 62 and d is equal to 3. So the question now becomes finding the 11th term with these a and d. So a12 is equal to minus 62 plus 11 minus 1 into 3 equal to minus 62 plus 30 equal to minus 32. So the 11th term, which is now the required term, is minus 32. Example 7. In a flower bed, there are 23 rose plants in the first row, 21 in the second, 19 in the third, and so on. There are 5 rose plants in the last row. How many rows are there in the flower bed? Solution. The number of rose plants in the first, second, third rows are 23, 21, 19, up to 5. It forms an AP. Let the number of rows in the flower bed be n. Then a is equal to 23, d is equal to 21 minus 23, equal to minus 2, an is equal to 5. As an is equal to a plus n minus 1 into d, we have 5 equal to 23 plus n minus 1 into minus 2. That is, minus 18 is equal to n minus 1 into minus 2. That is, n is equal to 10. So there are 10 rows in the flower bed. Finding sum of n terms of an AP. We will now use the same technique to find the sum of the first n terms of an AP. A plus d, a plus 2d, and so on. The nth term of this AP is a plus n minus 1 into d. Let us denote the sum of the first n terms of the AP. We have S is equal to a plus d plus a plus 2d plus so on up to a plus n minus 1 into d. Rewriting the terms in reverse order, we have S is equal to a plus n minus 1 into d plus a plus n minus 2 into d plus so on up to a plus d plus a. On adding 1 and 2 term wise, we get 2s is equal to n into 2a plus n minus 1d plus 2a plus n minus 1 into d plus 2a plus n minus 1 into d plus 2a plus n minus 1 into d. N terms, or 2s is equal to n into 2a plus n minus 1 into d, since there are n terms, or s is equal to n by 2 into 2a plus n minus 1 into d. So, the sum of the first n terms of an AP is given by s is equal to n by 2 into 2a plus n minus 1 into d. We can also write this as s is equal to n by 2 into a plus n minus 1 into d. That is, s is equal to n upon 2 into a plus a. Now, if there are only n terms in an AP, then a is equal to L, the last term. From 3, we see that s is equal to n by 2 into a plus L. This form of the result is useful when the first and the last terms of an AP are given and the common difference is not given. Let's work out some examples. Example 1. Find the sum of the first 22 terms of the AP 8, 3, minus 2. Solution. Here, a is equal to 8, d is equal to 3 minus 8 equal to minus 5, n is equal to 22. We know that s is equal to n upon 2 into 2a plus n minus 1 into d equal to 22 upon 2 into 16 plus 20 minus 1 into minus 5 equal to 11 into minus 89 equal to minus 979. Example 2. If the sum of the first 14 terms of an AP is 1050 and its first term is 10, find the 20th term. Solution. Here, S14 is equal to 1050, N is equal to 14, A is equal to 10. As S is equal to N upon 2 into 2A plus N minus 1 into D. So, 1050 is equal to 14 by 2 into 20 plus 13D equal to 140 plus 91D. That is, 910 is equal to 91D, or D is equal to 10. Therefore, A23 is equal to 10 plus 20 minus 1 into 10 equal to 200. That is, 20th term is 200. Example 3. How many terms of the AP 24, 21, 18 must be taken so that the sum is 78? Solution. Here, A is equal to 24, D is equal to 21 minus 24 equal to minus 3, S is equal to 78. We need to find N. We know that S is equal to N by 2 into 2A plus N minus 1 into D. So, 78 is equal to N by 2 into 48 plus N minus 1 into minus 3 equal to N by 2 into 51 minus 3N, or 3N2 minus 51N plus 156 is equal to 0, or N2 minus 17N plus 52 is equal to 0, or N minus 4 into N minus 13 is equal to 0, or N is equal to 4 or 13. Both values of N are admissible. So the number of terms is either 4 or 13. Example 4. Find the sum of first 24 terms of the list of numbers whose nth term is given by an is equal to 3 plus 2n. Solution. As an is equal to 3 plus 2n, so a1 is equal to 3 plus 2 equal to 5, a2 is equal to 3 plus 2 into 2 equal to 7, a3 is equal to 3 plus 2 into 3 equal to 9. List of number becomes 5, 7, 9, 11, so on. Here, 7 minus 5 is equal to 9 minus 7 is equal to 11 minus 9 equal to 2, and so on. So it forms an AP with common difference D equal to 2. To find S24, we have N equal to 24, A equal to 5, D equal to 2. Therefore, S24 is equal to S equal to 24 by 2 into 15 plus 24 minus 1 into 2 equal to 672. So sum of first 24 terms of the list of numbers is 672. Example 5. A manufacturer of TV produced 600 sets in the third year and 700 sets in the seventh year. Assuming that the production increases uniformly by a fixed number every year, find 1. The production in the first year, 2. The production in the 10th year, 3. The total production in first 7 years. Solution. 1. Since the production increases uniformly by a fixed number every year, the number of TV sets manufactured in first, second, third years will form an AP. Let us denote the number of TV sets manufactured in the nth year by AN. Then AN is equal to 600 and A is equal to 700. A plus 2D is equal to 600 and A plus 6D is equal to 700. Solving these equations, we get D is equal to 25 and A is equal to 550. Therefore, production of TV sets in the first year is 550. 2. Now, A10 is equal to A plus 9D equal to 550 plus 9 into 25 equal to 775. So, production of TV sets in the 10th year is 775. 3. Also, S7 is equal to 7 by 2 into 550 plus 7 minus 1 into 25 equal to 4,375. Therefore, the total production of TV sets in the first 7 years is 4,370. As we have seen some examples about finding sum of first n numbers of an AP, now let's work out an activity. What is the sum of first n positive integers? Tick the correct option and click Done. Summary. You have learned that an arithmetic progression AP is a list of numbers in which each term is obtained by adding a fixed number D to the preceding term, except the first term. The fixed number D is called the common difference. The general form of an AP is A plus D, A plus 2D, A plus 3D. A given list of numbers A1, A2, A3 is an AP if the difference is A2 minus A1, A3 minus A2, A4 minus A3, Give the same value, that is, if ak plus 1 minus ak is the same for different values of k. In an AP with first term a and common difference d, the nth term or the general term is given by an is equal to a plus n minus 1 into d. The sum of the first n terms of an AP is given by n upon 2 into 2a plus n minus 1 into d.